Hi, ladies and gentlemen. We are going to talk about determinants of 3x3 matrices. So we've already done 2x2s. You've done 2x2s with variables. Now we're going to do 3x3s. And I'm going to confess to you right now, this is tedious. And what that means, if you don't know what that word means, tedious is a word that means it's stupid easy. And I mean like crosswords. No, not crosswords. Crosswords are really hard, actually. Word searches. That's the one I'm thinking of. Word searches. It's like word searches that your history teacher gives you. Right? You just stare at this thing until you find the correct letters in the correct order, and then you circle them, and then you're done. But maybe I'm just bad at word searches. I can't finish them in less than half an hour or something like that because it's just so labor intensive. You just have to sit and stare at it, and then, oh, I found it. It wasn't any work, and I don't know that I learned anything from this, but I found it. It just took me 5 minutes of searching, looking for all the letter T's for tedious. So that's kind of how 3x3 matrix determinants are. They're not hard. It's nothing but multiplying, adding, and subtracting, but it's a lot. It takes up a bunch of space, right? So we're going to find some 3x3 determinants today, and hopefully it's not too painful, but it might be a little bit painful. But we'll do our best. We'll tell some jokes along the way. We'll laugh, we'll cry, we'll commiserate, we'll sit and reminisce about the good old days, and then we'll learn how to do some matrices. All right, so let's just go ahead and get the bad part out of the way. Let's talk about how do you take the determinant of a 3x3 matrix. So here's an imaginary 3x3 matrix, and it's just got a bunch of letters in it so that we can kind of track them and see where everything comes from. So 3x3, to take a determinant of a 3x3, here is the formula for it. And you're going to say, wait a second, Barton, what in tarnation? You said what? You want me to do what? All right, let's break this thing down, and then we will go do a couple examples. So the determinant of this 3x3 matrix is A, so this right here, times the determinant of EFHI. Let's go look at EFHI. The place this comes from is when we take A, you are blocking off everything that lines up with A horizontally and vertically. And then the stuff that isn't blocked off, you take the determinant of that tiny matrix. You're going to say, determinant? Yeah, you have to do a 2x2 determinant, and you're going to notice that thing is here 3 times. So to take a determinant of a 3x3 matrix, you take 3 determinants of 2x2 matrices and multiply them to some numbers. Okay? So you're going to take the top row, and you're going to bring those down and make them coefficients. The important part here is that the B has a negative sign in front of it. So if this were, say, B equals -3, you got a -3 right there. This would be +3. The sign changes. So A and C stay exactly what they are. Change the sign of B. Then we take the determinants of the things that aren't blocked off by those letters. So for this first one, our determinant is EFHI. We've already seen you block off everything that lines up with A, vertically and horizontally, and that's the determinant of the stuff that's left. For B, it's the exact same thing. For B, we block off everything that lines up with B, and now this DFGI, like pretend this isn't here, DFGI. So it's these 4 elements that are not blocked off. Same thing with C. If we block off everything that lines up with C, you take the determinant of what's left, DEGH, DEGH. All right, clear as mud, right? So this is how we're going to take a determinant of a 3x3 matrix. I'm going to show you this process on one example, and then I'm going to show you another way that we can kind of shortcut this so that it's not quite as cumbersome and maybe we can get it a little more consistently. But we'll do it the way the formula says the first time. All right, let's go try that. So we want to start by finding the determinant of this matrix. The first thing I'm going to do is I'm going to take my 3 first row elements. I'm going to go ahead and write them out. Make sure we change the sign of B. So we're going to have 2 times the determinant of something minus -3. So we'll change that to a +3 times the determinant of something plus C. So 1 times the determinant of something else. Ooh, I shouldn't have written so big. Can I just move everything over? Absolutely I can. There we go. All right, that looks good to me. All right, now we're gonna fill in our matrices. So for A, cross out everything else. So this is gonna be 1, negative, or sorry, that's not a 1. 0, -1, 4, 5. Cool. All right, now we've got to look at B. Cross off everything that lines up with B. So the inside of this determinant will be 2, -1, 1, and 5. And now for C, we block off everything that lines up with our C term and then take the determinant of this little matrix. So 2, 0, 1, 4. All right, we have the problem set up. Now let's go and simplify this thing. So I'm going to just bring down the coefficient. So we have 2 times. The determinant of a 2 by 2 is A times D minus B times C. So this is going to be 0 times 5. Let me put this inside some parentheses. 0 times 5 minus 4 times -1. All right, that's the determinant of this matrix. Now +3, parentheses, and we're going to put the whole determinant in here. So we have 2 times 5 minus 1 times -1. All right, one more. Bring down our +1 times. Then we're going to fill in our determinant. So 2 times 4 minus 1 times 0. All right, now we just clean this whole thing up. So 0 times 5 is 0, and -4 times -1 is 4. So this is 4 times 2, that's 8. Here, 2 times 5 is 10, minus 1 times -1 is +1. So this is 11 times 3, so that's 33. And then here, 2 times 4 is 8, 1 times 0 is 0. So 8 times 1 is 8. Then we just add these up. So 8 plus 33 is 41, plus 8 more is 49. And that's our determinant. You could type that in on some kind of calculator and then check it, but there we go. All right, you're gonna say, Barton, that's too much. Barton, how do you keep this mess straight? Barton, I'm ready to give up on this, Barton. You know what? I just don't think I'm cut out to be a mathematician. You know what, Barton? I just don't think I'm gonna make it. You're gonna be fine, kid. Don't worry. I'll hold your hand. You're fine. Breathe. And exhale. All right, you're fine. Breathe. Don't worry. You got this. I believe in you. Your mom believes in you. Your dog believes in you. We got this. Let's go do another example. All right. I understand that last page is a little intimidating and there's a lot of stuff to keep straight. So let me teach you something that a very beloved math teacher I had a long time ago taught me. I had, like you, a math teacher in high school teaching me pre-calculus. And she taught me this wonderful trick that helps us do the determinant of 3 by 3 matrices without having to use this abomination. And I'm going to be frank with you, I like this. I think this is pretty. This looks nice. But you know, that's my personal opinion. So you're not obligated to agree with me. But I also like math and dill pickle flavored pretzels and I don't know, struggling, you know. I like fractions. So that tells you what kind of sicko degenerate I am. So let me teach you another way to try and do your determinant that maybe you'll like a little bit better and maybe isn't quite so scary. So what we're going to do is we're going to take this column and this column. We're going to copy paste these right here at the end. So what that's going to look like is I'm going to copy this one. So 2, 4, 2. And then I'm going to copy this one. 1, 3, 1. All right, and now you're going to have to let me lock these down so that I don't accidentally erase them. All right, so now one way that we can find the determinant is we can multiply the diagonals and then add and subtract them. And let me just show you what I mean, because this is another way we can get the determinant. So what we're going to do is we're going to take all of the diagonals this direction. We're going to multiply these numbers together. Then we're going to take the diagonal this direction, multiply these numbers together, take the diagonal this direction, multiply these numbers together, and then we add those three things up. Then we do the diagonals the other direction, those three, and those three, multiply them, and then we subtract each of those. Okay? So now let me show you, let me do that, and we'll see our determinant. So let's start with this first diagonal. 2 times 3 is 6, times 2 is 12. Write that down. Next diagonal. 1 times 5 is 5, times 2 is 10. You put a plus sign. If this were negative 10, you would put minus 10, but it's plus negative 10, so plus 10. One more. 1 times 4 is 4, times 1 is still 4. So plus 4. Here we go. So 12 plus 10 plus 4 is 26. All right. Now we do the diagonals the other direction. I'm going to erase my circling here so that we can see stuff. Let's do it in a different color. Let's do green. So now we're going to do the diagonals in this direction, and we're going to subtract each of them. So 2 times 3 is 6, times 1 is 6, so minus 6. 1 times 5 times 2 is 10, so minus 10. And then 2 times 4 times 1 is 8, so minus 8. So this is negative 16 minus 8 more is negative 24. And 26 minus 24 is 2. This process will work on all 3x3 matrices. What this is, or where it comes from, just in case you're like, Barton, how are there two different ways and why is one so much easier than the other? If we look at this determinant, we could simplify all three of these. This determinant is actually E times I minus H times F, and then that's times A. So what they did is they rewrote these three determinants as these binomials, right? This one is DI minus GF times negative B, and then plus C. This is DH minus GE. And then they foiled your coefficients in, and then they kind of looked at the pattern here, and they found that this formula means sum up your, or find the product of your diagonals and then subtract the products of your anti-diagonals. And then it means the exact same thing. That big scary formula simplifies to these diagonal thingies. So it's the same thing. These diagonals will work for you, and hopefully you're not terrified. If you are terrified though, I have a WebEx meeting where you can come in a safe place. You can say, Mr. Barton, you know what, I've learned to face fractions, but then an even scarier threat appeared, right? The Hidden Leaf Village was minding its own business, and next thing you know, Kamigawa, or never mind, I'm just making stuff up now, right? All the Naruto fans are bleeding. They're like, oh, Barton, he doesn't even know about the Hidden Leaf Village. All right, you guys, if you need help, you know where to find me. Have a great day.